first question is, let's define software craft. So what does that mean to you? Like, what do you care about software craft?
Software that don't break.
Oh.
Software that don't break.
Okay.
Doesn't break. So,
software can read in 6 months.
Yeah, reading is very, very important. Anything else? Or
applying the right tools and technology.
I have a very selfish motivation for software craft. I like sleeping. I don't want calls in the middle of the night. So that is that's where I started to get into it, is those, software will break. It will hopefully break less as our, development practices grow. So that's what that is. And as far as defining it, it's very fluid. It's going to be really hard to really measure what it means, mainly because it actually depends on your application. You don't need a super domain-driven design for a small CRUD application that's going to live 2 months. It's overkill. So fit for purpose is a big deal when it comes to software craft. It's not one size for everything. So who I am? So I'm Ben. I've been working at EPON now for about 7-ish years, consultant, all that. My core skills is Spring Boot. So most of my examples will come from that, though I've done some Node.js and other things, but thankfully it's a Java conference, so at least it's in this room's warehouse. I'll be talking a little bit about tech leadership because software craft starts with the tech leads in the organization more than just the engineers. It's a team sport. We all have to work together to do this, especially at the enterprise. We're no longer coding by ourselves on our school projects and all that. And so it's all about how do we get the team to care about software craft and enable them to actually achieve those goals. That is how we get there. And then the purpose of this talk is to enable you to convince your boss, your organization. If you were there at a keynote, you can use his techniques on top of this talk to give you more tools on getting there. So, questions. Who are they? If you recognize them. Yes? Yes? Probably. At least we're very relevant things. I haven't met them in person, so I will assume they're very smart. And yes, they were the founders of Agile. They kind of wrote that manifesto along with others. But the key aspect I want to highlight here is that they are developers. Very, very competent developers that founded Agile. Which, if you're newer to the tech community, it's actually kind of weird because developers now hate Agile. It's annoying, too many meetings, can't code, too many metrics, especially the big enterprise. And we're always talking about reducing the ceremonies and Agile-ish stuff, but it actually comes from developers. And so I kind of want to bring that back. How do engineers care about Agile, why it matters, and how to enable both sides. It's a bit of a rant of the Agile community because it got overtaken by project managers and all that, and they left the developers behind. And it's not that we don't need good project management, we do, it's just we need both sides. It's come together on that. So this is not about getting rid of Agile, it's about using that on top of tools. Any questions about that? I don't want to stay in Agile too much. Let's talk about test-driven development, because that is, so I'm a coach. I'm a coach right now at a client. The number one reason people hire me is to teach test-driven development. And my number one thing I do when I get there is to tell them, you don't want test-driven development. You want software craft. Because actually, test-driven development is not something that will solve code quality issues. It's something that will come eventually as part of your tool set. As you care about software, you'll want to do some test-driven development sometimes. But it isn't actually what enables it. And there's a few reasons behind that. If you're not working on a new application in legacy code, test-driven development is really, really hard. Like mocking hell and all that, it's going to be really slow you down. Learning how to test effectively, if you're doing test-driven development, it's kind of hard to do as well. And then the last part is learning. It's very easy to do in workshops. Like it's set up a Fibonacci sequence, test-driven development, or some other mathematical aspect. But then you get into production level code. Suddenly it gets hard. Like how do you do that with Hystrix and your resiliency? You just need to know testing really well and writing code well to eventually be able to adopt test-driven development. Now, what I mean by test-driven development, since sometimes it's confusion, I'm the strict term of test-driven development. Unit test only. I'm not talking about acceptance test-driven development, the more integration level aspects. Any thoughts? Yeah.
Where do you draw the line between unit test and integration test? Because I see a lot of source repos that have their test folder, where all the unit tests are, and there's tons of stuff in there that includes integration assertions.
Yeah. So if you're in the Spring Boot world, if the Spring Boot context is up, it's an integration test. I don't care what it is doing, it's an integration test. Even if it's only talking within services and all that. Anything that talks to external, like database, or REST endpoint, event, whatever, that's an integration test. As soon as you're not mocking something, it's an integration test. Again, it can be fluid. Sometimes it's easier to not mock a service because it doesn't make external calls, so you're testing 5 services at the same time. Is that an integration test? Is it a unit test? That's where you don't be dogmatic. If the test is better written with testing 5 services, that's fine, do it. What's the purpose of testing?
To discover your problems before anyone else.
Yeah? Anything else?
Unintended consequences from changing the code.
Yeah, it's like a safety net. If you've been working in a place that has lots of testing, and then suddenly you go somewhere that doesn't, you just get scared about code because you just start to rely on that safety net. It's also about design and other things. Test-driven development is actually more about design than testing. The test suite out of that is secondary behavior. What is enough test? Do you have code coverage requirements at your company? What is it? Okay. What's the right number? Well, how would you decide on your service what is the right number? It's a question I used to get all the time.
My guess is there's sort of a power law curve on the severity of impact for any of the things that may or may not be covered. So how are you going to know which end of that curve that code is in?
For me, it's when I can merge and walk away. If I'm confident that it's going to work by merging and then going home, that's enough test. Is it 40%? Is it 95%? Who cares? Can you actually walk away after deploying and merging it? Also, it depends on your level of care. If you actually truly don't care, then that could be a problem. But
so I would say the percentage matters. So there are cases where you introduce a new line of code, and that introduction, requires you writing tests.
yes.
So in our case, we set our percentage at 95%, so that when you introduce that new line of code, you want to make sure that the test is written. So let's say you introduce that new code, you merge, it's going to pay the bill because you write tests for that new code.
Yeah. So I normally require a very high percentage line coverage. So I'm not saying advocating for 40%. What I'm advocating is that you care more about walking away than the metric, because it is really easy to get to 95%. You just don't add asserts, just run through the code.
So I agree with you that the right amount of code coverage is how much tests you need to be comfortable with the system works. But everybody is different. Everybody has a different threshold for their level of comfort. How do you enforce across the team, like, to uphold the standard of we should test to this amount?
So that comes from like peer review and going through PR reviews and all that. It's not just the developer who has to be confident. Who okayed that PR? Are they confident as well? So now you're going back to that team. It's the team's responsibility that they are confident that it goes.
Did I hear an extra factor get thrown in there, like developer review? So like maybe one situation, people are relying entirely on unit tests. They throw it over the wall, the test went green, everyone should assume it's great.
Mm-hmm.
But in another situation, someone's looking over your shoulder and you get to ask them questions. Those are different, right?
They are, yeah. It does depend on your SDLC process. How does code go from laptop to prod? Do you have reviewers in place? Are the reviewers effective? Or are they just clicking that approve button? Or are they just doing syntax stuff? Or grammar or wording, like nitpicky things, but not talking about designs or finding actual problems. Like, it goes back to that culture. You need people to care to do good, proper reviews. You need your developers to have time. It's one thing, like if their workload are so heavy that they can barely finish their work, they're not going to have time to review. That goes back on management, like, hey, we need to make sure our estimates include proper review standards. Those standards will depend on where you go. I've worked at banks, really high-level stuff, big teams, slow velocity because it's a bank. Working at startups, it's like super fast. We just keep cranking out code like crazy, and the reviews are kind of hard to get on time. So there will be differences. It goes back to, are you confident it's going to go? Or you're confident you can fix it if it breaks. How fast can you do it? That's the consideration as well.
If you have 100% coverage policy, does that create an incentive to not put assertions in?
So 100% for me is unrealistic in the sense that at some point you have to have catch blocks because the compiler tells you to have this catch block on an edge case that will almost never happen. How do you truly trigger those things? It's really hard to get it. 95% that's okay. Depends for your legacy. 95% is very easy on greenfield. You just start with it, and then you just maintain it. Getting there on the old application is a lot of work. So that would ramp up and use some Git tools to figure out where the best to focus, like testing, refactoring. Best way to get to that coverage is delete. Delete, delete, delete. It's the first thing I do when I go to a new place to coach. I look for everything that's unused, start deleting code. You can get it back in Git eventually. At least you don't have to test it. So, how do we measure that we're good at it? I'll talk a little bit about this. These are the 3 metrics I use, particularly with business. Sonar metrics that are very important. I still use them. I look at complexity. I look at code coverage. I look at readability, all those type of things. But at the end of the day, we are working for a business, and producing value matters. So that's how we measure. Like, software craft has to enable the business to create more value. So that's time to market. How fast do we get to that market? You have to understand the scope of what's in that time to market, and then your scope of impact. So what I'm talking about here is the true measurement, which is idea to customer. Sometimes the issue with time to market is not developers. It could be product that takes forever at getting the requirements, and that flows kind of off. Sometimes it's on the other side, like customer success, where like you've been pushing stuff, but they don't actually enable that release for their customers. It's not always in the realm of developers. So when you talk to business about increasing time to market, it's good to talk about the surrounding areas, what's coming in and how it gets to the output. But your impact may not matter. You have to understand where in that software lifecycle you have an impact. And then when you add practices, that's really what you measure, is where you have impact. You can have influence outside of it, but you have to be aware of those 2 measurements. Measuring that is typically pretty easy on the developers. It's Jira tickets. When did they get created? When is it done? Because created is sometimes like the easiest metric for like the idea. Somebody had an idea of it. It's not just when it comes to the backlog. It's when it got created. And then you can add a measurement on from the once inside the sprint to actually to the customer, all that. I don't know how to set up Jira to do that. I rely on Jira people, Scrum Masters, or those people that can actually manage that well. But I'll ask for like those kinds of measurement. Sometimes I use Excel if it's easier. I'm not too dogmatic about like the right measurements. It's a trend. Like general area is okay. I want to see that as I introduce SoftwareCraft and some applications around it, that measuring gets better. That's also how you go back to your business and be like, hey, we slowed down, we added peer reviews, we added unit testing and all that. And over time, our delivery is getting faster because our QA cycle now is being reduced. Or some other reasons, like features can be added faster because we are doing proper dependency injection, domain-driven design. It's easier to add new features. There's reasons behind it, but you can measure that impact outside of code. It's on the business. So that's how you get that kind of buy-in. The other two, they go in pairs. Mean time to discovery and recovery is when there's an issue. We all know there will be issues. How did you discover it, and when did you discover it? That's of these three metrics, that's the hardest one to know. Well, actually, no, that one's easier. Well, it is hard to know because the end state is the ticket. When was that ticket created? So that's when it was discovered. But when was it introduced? Was it a commit? Was it a missed requirement? Was it miscommunication? That could be fuzzy at figuring out when that happened. If it's a commit, you could do some research, find the hash, the date, timestamp, and then you have that mean time to discovery. If it's not code, that's way harder. Like, was it a missed requirement? When was the meeting? That could get fuzzy. So don't go hunting that too much. Just, again, get a general idea. And then recovery, that's easier. Whenever that ticket is created to resolved in production, not just in test or in laptop. It's when it goes back to the customer. Now, these three metrics together provides, like the analogy I like to use is your highway. What is your safe speed? So time to market is how fast you're going. And then the other two is your speed limits. If you're really good at mean time to discovery and recovery, you can afford to introduce issues in prod. Depending on your SLAs, it depends, but like the risk factors, that's another one. But you can go faster and be like, oh, it only takes me 2 hours to go from laptop to prod. That's pretty fast. If it takes you a month, you better slow down and be sure that your ducks are in a row. So those are three measurements that I use. That resonate with anybody? Do you want to use other measurements?
I was going to say, like, in your time, it's sort of like, to use it as a metaphor, when something goes wrong, it's like, we like to say something's blowing up. There's two dimensions to that. There's like burn time and blast radius.
Yep.
So you have to kind of understand both in order to estimate your risk.
Yeah, risk will have a big part of that. It depends on, like, is it a customer-facing app? Does it move money? There's a bunch of different things on it. Is it an internal app that enables, developer productivity? There's way different levels of risk when it comes to deploying in prod. I don't measure that one. I just ask my client, like, what's the risk tolerance here? And adjust based on that. It's a good question to ask your product owner. Do you know the risk tolerance of your project? Do you have SLAs? Do you know your SLAs? As developers, you should ask this question to your product owners. Sometimes they're there, sometimes not. A lot of times they are there, they're just not communicated. But it should have an impact on how we code, because we are supposed to meet those SLAs. And it will help you define your practices and what to change. Now, how to actually affect these things. This is me. This is the way I put them. My opinion. I can be wrong, and I created this in like 5 minutes, so you could expand all that. But I wanted to kind of measure, going back to that test-driven development. We're like, hey, that will increase software craft. Test-driven development helps with design to testing in SDLC. It doesn't help with IDEA. It doesn't help with prod and pushing. So when you're looking at your time to market and your scope of impact and your slowdowns, it's important to know what you're trying to improve. Or if you're introducing techniques like dual-track agile, are you actually getting better ideas in your backlog? Is your innovation steps improving? That's what dual-track agile is for versus other ones. Is there anything on this that you don't know that you would like me to define?
You touched on it multiple times that TDD helps with design. Can you elaborate on what you mean by that?
Yeah. So doing TDD requires mocking. Are you familiar with mocking? Mocking requires that you can do dependency injection. You need to be able to replace an object with a mock. The best way to do that is via dependency injection. Dependency injection is a requirement for good design. Okay. That's actually the one dogmatic thing I have is dependency injection. If I go somewhere and they're not using a dependency injection framework, that's the first thing I start to put in place. Other parts of design is testing is hard. It's way easier to test good design than bad design. We have methods that are thousands of lines long. How many conditions are in there? How many permutations of this method? You end up writing thousands of tests just for that one method, just because of how long it is. It'll be a better design to break apart the responsibilities, makes testing easier. If you write your test first, then you start to not go into those issues, but it's typical to write these big methods as you brainstorm. Talking about big methods, I write really bad code at first. Still now, and I teach about software craft. And my first pass is horrible. It's this huge method, it does everything, all that. I'm really looking for the success. Does this work? How fast can I make this work? And then I start refactoring. And that kind of starts to help me on that. It also helps with developers to get that mental block. When I coach, they're like, oh, I'm supposed to write good code. How? And it's just analysis paralysis on the right design. It's just get it to work first. Then clean it up, rename things, break out apart the functions, start doing a factory by pattern or not. Doesn't matter, but at first get it to work, then clean up. It's also why I think developers sometimes get in trouble with business is you estimate that first pass. You don't estimate that refactoring, and then it's done. So that goes back to us being professionals. Done is when it's appropriately done, not just the first pass. And then you had a question?
Yeah, on the screen I was just wondering how do you differentiate that test-driven development and then that accepted test-driven development?
Yeah. So accepted test-driven development is, in my world, it's a black box test. Sometimes you use Cucumber, you don't have to, but essentially, if you have a REST service, you make an API call in, you read the response back, and you validate the response, and that's it. You don't go inside the application to try to figure out what that is. So the reason why it works for deployment and released is depending on how you design your acceptance test, it can run in Jenkins on the service that's being worked on locally. It can run on your laptop. But in your CI/CD pipeline, you could also point that same test to dev, to QA, to prod. Run the exact same test since you're just doing REST endpoints. You could validate after deployment. Prod is tricky. It depends if you can actually test in prod. There's some, sometimes you can't. You should at least be able to test the health check endpoint. I'd like to have that one as a acceptance test, where I just hit my health check, I get a 200, app is up, I can run that one in prod. after deploying. Have you ever had an issue where, especially your Docker containers, like your Docker container is up and healthy, but the app isn't? The app itself just keeps rebooting? And your pipeline just says green? That happens to anybody?
They just check the code.
Yeah, so having that health check endpoint, like you get a green pipeline, like it will force the pipeline to fail if the health check fails. Better notification. So it's a very simple test to write, but now you don't have to go check after deployment to see if the app is actually up. And sometimes you can do more than just that. Maybe there's Git endpoints that you can use that don't modify the system that you can use in prod. Any other questions here? I'll pick one or two more if no one wants to. Trunk-based, yeah. That's actually a very good one. I have a good story about that. I've been coaching for a while, and I go to this place, and they're like, hey, you want to go to trunk-based development? Can you coach us to get to trunk-based development? I had to go Google. I don't even know what trunk-based development is. So I started Googling it, and I was like, oh, that's just development, like normal development. Like, what are you talking about? So if you're using GitHub Flow, GitLab Flow, I don't think Git Flow is, but those two are trunk-based development. The idea is everybody's developing off a trunk all the time. No branches and all that. That's the very dogmatic way. But as long as you're doing feature branches and those feature branches get merged in fast-ish, it's close enough to trunk-based development. Sometimes you're going to have long-lived branches. It's really hard to merge big refactors, every week. But if you merge trunk into your feature branch and you don't never stay far from trunk, you're getting close enough to that. That's what trunk-based development is.
The way I've seen people define trunk-based development is you have the main branch, features off it, come back into it, there's no develop branch, there's no QA branch, there's no releases, everything's right there, going immediately to production.
Yeah, and that's what you just described is GitHub Flow. GitLab Flow still has name branches, but you still pull from master, and then master gets merged to dev gets merged upwards, but no code. That is still a form of trunk-based development, and there's some reasoning sometimes behind it where you need to have a name branch for environments. Let's see if I can come up with examples. If you're doing fail forward or like going to master all the time, but you're not always deploying to prod, you have to have a button. It can be hard sometimes to know what is in prod. And you have to go figure out the last deployment, the hash, and it's like 10 commits behind. And so that could be difficult. Having named branches enables you to know exactly what is in prod, even though you're following the same practices of trunk-based development. Sometimes you need it if your application has to be installed. So if you're not in web app world, web app is really easy to do trunk-based. Everybody gets update when they refresh the browser. What if it's installed? How many versions do you support? It's harder to do trunk-based development in that world. Like operating systems, as an example. How many versions do you support? Any other questions? No, sorry. Just all the cameras here.
I noticed that QA review is included as one of these. Is that responsibility been offloaded somewhere else?
Testing. So QA is an interesting topic. A lot of times when I go places, QA is the organization that really fights me because I'm like, hey, we want to do some testing and we want to shift left everything. And they're like, wait, but that's my job. Well, what are you doing? And so I like QA. I love QA on the team for their mindset and their ability to find issues that were not diagnosed. However, if you're a QA engineer that just goes through scripts and you manually do things, that can be automated, and your job is at risk in modern development. There are times where that's more effective because writing tests can be expensive, and so there's trade-offs to do there. But for me, testing and validation is a whole team aspect, whether it's manual or not. And manual will always have a place in software development. Exploratory testing, anybody heard about that term? It's an example of manual testing that's very effective. Exploratory testing essentially is, as a team, you write a charter around this feature has a lot of issues in prod, or we just did a whole bunch of changes to it. We want to really validate this particular area of the code base. And then everybody just starts experimenting, clicking around but on that focus.
Is that the same as like red teaming?
Maybe, I'm not that familiar with that term, so.
Like or white hat hacking, where you carve off like a portion of your team and their job is now to break what you're about to deliver?
Yeah, it's essentially that. Or you keep getting production issues on a particular feature, and all your tests keep passing. It's like, that means that you don't have a good enough set of tests. There's gaps in your testing. So exploratory testing is that. Find the issues, figure out how to identify those issues proactively, write tests about it, and improve your regression test suite. But that takes a QA mindset to really lead that effort.
So do you see QA as like a distinctly different part of the SDLC, like it's outside of?
For me, it's part of testing. Testing could be automated, it could be manual, it could be part of sprint work. The whole team could be part of it. Sometimes the product owner is our QA. If it's a web app, they can validate that. So, anybody heard of that T-shaped thing that Agile talks about? Like every developer should be T-shaped, where you have like your deep expertise and then your side things. So you're really good at API development. You dabble in some DevOps, and you dabble in Scrum Master things. Agile loves to talk about that. I throw that back to Scrum Masters and my product owners, like, yeah, you can be T-shaped too. You have deep expertise is product and writing that, but you can also dabble in QA, also dabble in some other things as well. Like we're all delivering, like be part of that team and deliver. Incentives are a big deal. How you measure delivery and productivity will have a huge impact on this. The example I like to give is senior development or tech leads. I've been in places where the tech lead is supposed to deliver the most features. Biggest story points allocated is to the seniors and leads. And other reviews like, hey, you're not quite delivering as much as we expected, so we can't give you the raise, blah, blah, blah. That is bad measurement. Juniors, okay. We can measure productivity of juniors. They need to learn and deliver and all that. The more senior you are, the more it's about team delivery, organizational delivery. How are you enabling those juniors to deliver more code? Are you teaching them the good practices? So if you're a tech lead, like you shouldn't actually own stories. I don't own any story on my teams. I do a lot of coding, but somebody else owns it, and I'm on every story, and I'm reviewing, I'm refactoring, mentoring, or if they're blocked, I go figure it out and push to their branch. I'm just all over the place, but as a lead, you're a force multiplier. And that's more than just writing code. And that's how you measure it. So if the team productivity goes up, that's a good tech lead, not just their own. Interest of time, let's go to the last one. What kind of practice can improve mean time to discovery and recovery? I put chaos engineering in here. I've never actually done it. It's talked about a lot. It's when you proactively like break stuff in prod. Netflix wrote a book on it. Actually met a Netflix person yesterday, so it was my first time. They actually do it. But these are what you can work on to improve that other metric. And those are techniques you can introduce to your teams or do it yourself. Anything on here you'd like me to touch on, talk about?
Is Canary deployment basically like a staging environment?
So it's a service that acts as a canary, and it goes into all your environments. The way we used it is to test our pipeline. Every time, because pipeline is also code, it's not just in a GUI, you change the pipeline. You commit your changes to the pipeline, infrastructure as code and all that. And as soon as that's deployed, you need to test that you didn't break your pipeline. So it goes and deploys and builds the Canary service and puts it all the way in prod. And then you have some alerting and monitoring that says, in elk or whatever, your logs, it will say, I'm up, I'm up, I'm up. And whenever it's not up, you broke the pipeline. So that's an example of Canary. You're looking for something to say, hey, I'm not working. You can do that sometimes in other ways where, with like seed traffic, it can be a bit of a canary. Anybody familiar with that, or do seed traffic? So an example, I was working at a bank, and they essentially set up a customer that buys coffee every morning at 10. The coffee costs an exact amount, and they have an alert if that coffee has not been purchased. Payment processing is wrong. Something's wrong with my payment processing because that payment is not there. That's a single one. You can also go with like the metrics of throughput. You do thousands of API calls on average per hour, per day, per whatever. What is your that? So you can do some alertings. Hey, we're at 50. Hey, we're at 1 million. You're outside of the norms, and you can send alerts. That's what monitoring and alerting. Some tests are better to write that way. If it's really hard to unit test and not really hard to integration test, you can do testing and using a monitoring solution. And that could be sometimes easier.
What do you mean by self-healing?
That one's hard. It doesn't heal itself, but sometimes it could like resolve its own issues. So example is you have a batch things, and it has to call something. That service is down, your whole batch system went down. Somebody has to go in and fix it. Can you have a proper state machine that you can retry, redo failed request eventually because you've identified that, hey, actually that request is fine, something else is down. Now you've essentially, like the application heals either via retries or other things in state management so that you don't, as a developer, you don't need to go in and manually go into the database, figure out the state, and heal that. The way I implement that is I don't design self-healing architecture at the beginning. It just works happy path with some error scenarios. And as we start getting issues and resolving a lot of the same issues, like, okay, well, can this issue resolution be automated? How do I add that to my code? So I would have like batch jobs, schedulers that inspects the state of my state of a request. I had some that were really long, it takes like an hour to finish. Hey, that one's been around for a whole day. Something's wrong. It would, alert me. And then it was like, can I put it in the previous state and see if it triggers again? We're using event-driven architecture, so that was actually pretty easy. If I change the state to the previous state, it will reprocess the file, essentially, send out all the events, the state would change, and it kept going. So that's an example of it. It will depend on what you're doing. In the end, it's what makes sense for you. Like, you slowly build that up, but those measuring aspects, you have to know the trend. Are you doing? Is it going better? Were your assumptions wrong? Like, you introduce all that and everything slows down and nothing improves. You're either introducing them badly, the developers are not ready for it, or they were not needed and the problem exists somewhere else. Any other questions? So the last part, this is the way I do it, how I introduce software crafts wherever I go. For me, it starts at code reviews. It's like an absolute requirement on that. And the reason why is code reviews create an opportunity for discussion. People meet and talk about code. So that's a mentoring aspect. You can critique the code. You can agree on it, disagree. It just creates an organic way of doing that. If you don't have peer reviews, it's way harder because now people will feel like, oh, what did you come look at my branch? What, do you not trust me? Like, it creates that mistrust. But if the process is in place for that inspection and talking about code, it's a safer place to talk about it. So you can introduce that mentoring aspect. Let's go back to the next stage. As a coach, I will mentor. I succeed in your organization if I'm no longer there and mentoring still happens. Like, it has to be organic. You have to believe that mentoring works, that code reviews work. Like, I have to leave to see that, but it's really, really important. Then I start introducing some metrics, like the ones I showed, and I start choosing some of these practices based on what I believe would help in this particular case. And I remeasure over time to see if it's trending in the right direction. You have to know that the metric will actually go bad first. Every time you introduce a new skill, everything slows down, it's worse, then it gets better. So you have to allow enough time, but not too much. Sometimes you have to step away from that. And then you just look at competencies. Well, what else should I introduce? Definitely don't introduce everything at the same time. Just one by one. Which one will succeed? If you're trying to create a snowball effect, introducing the right thing is not the right way to do it, even if it's what they need. For example, they really need test-driven development. But that might fail. Many developers hate it. It just does not work for them. Choosing something else that succeeds, that gives them momentum, will give you credibility to then introduce test-driven development. So getting that momentum is really important, especially on the business side. You want to show progress. So that's my methodology around introducing it. It's slow and steady, pragmatic, and then team measurements. And anybody can do this. Like, it's any questions? Did it help you answer the questions from the beginning? How to talk to management about it?
One of your slides had clean code as part of it. Do you put any weight on like structuring actual commits in a good way, or is it really only the end result of the code? Because I mean, I see so many pull requests that have 100 commits on them that, like, you know, the code was added, removed, changed this.
So on the pull request, I don't care. I like squashing. I know it's controversial. But I do like squashing and having one clean commit at the end. That's my way of doing it, because I do want people to commit often. Like, I use commits locally all the time as a save point. Sometimes I go down the path of experimentation. The easiest way to stop that path, git reset -- hard head. And then you're back at your previous save point. And then you keep going. So I do a lot of commits myself, but then I squash.
When do you find the best time to do code reviews? Because like I'll find I'll have a gigantic PR ready, and I could do the code review, but my teammates, they just don't have the same context. Or like,
I like opening the PR as soon as you start the story. Like, essentially, you put that in progress, you make a commit so that GitHub or whatever will let you open up a PR, and then you open it. You mark it as draft. That lets other people kind of review comments along the way, especially for like juniors or mid-levels. They may be going down the wrong path. You don't want them to finish their work and then like you want to redesign the whole thing because it was wrong. And it's an effort to get all the code into your machine, inspect it there, see the diffs. So I like opening up PRs right away.
Want to show a view on pair programming and all of this?
As you wish. Again, it goes back, for me, it's the same as test-driven development. I like pair programming. I've worked with people that just hate it. They can't type, somebody's watching them, and it's stress. And are they effective or not? And plus, pair programming is a tool. If I'm writing a complicated domain logic, pair programming is very effective. If I'm adding a bunch of REST endpoints with POJOs, really? Like, choose when to do it. So I like my leads to go from individual development, pair programming, and mobbing organically throughout the stories. I love mobbing too. At the beginning of a big story epic, we agree on the design, we create the skeleton, the code path, and events that just goes through, and then we can break off. Like, hey, we got the hello world going through all the different services together. We agree on all the contracts. We did that as a mob. Now we can go into pair programming and eventually individual. It has to be organic. It can't be mandated. But it's also the fastest way to do PR reviews. I do tell people, if you pair program through the story, it's reviewed. You can mark it. So if you hate big PRs and reviewing code, pair programming is easier.
Don't do big PRs.
I tend to do big PRs, so I'm sorry if I'm ever on your team. I like the code to be like cohesive, and sometimes the PRs story is going to have to be big. I like big stories. I want my stories to have a business impact, not be a task. I don't mind having multiple PRs for the same story. Some places don't like that, so it depends. I want my product owner to write the story. The only way my product owner can write the story is if it's business. They can't write me technical enablers or task level stuff. That's on the technical team to do.